Hello. Last time I did a current measurement and burden voltage comparing these three meters, and I would like to do the recap with because all these three is pretty very low burden voltage, and so to compare, I bought this when I was in high school, manual range. When I was looking for a device to measure the fan noise, I was trying to change the fan of the hard drive storage and the computer. Wanted to have some device to measure the sound level, and end up buying a multimeter because this had a mic and also a lux sensor. So end up buying a multimeter, but it's good for comparing the. It's good to comparing with a 3 good meter with the 2 cheap multimeter, and one is diddly old one. Okay, last time I was measuring USB serial port voltage and current, and voltage won't change, but the current will change based on the typing the keyboard on the serial port. So today, for the consistency, I decided to use power supply. And before I go into these meters, this is 121 gigawatt or 121 GW multimeter, Keysight U1241 and Fluke 87.5. And the reason I bought this is because this was my first digital multimeter I bought when I was in high school. And you could clearly see this is a knockoff of the Fluke. And if it's more looks similar if you take the cover off. So yeah, even I was in high school, I could understand this was a knockoff of the Fluke. So when I was in high school, this was the second cheapest multimeter. I was in the shop in Akihabara. This was, I think it was about 50, little bit over 50 or $60 in US dollar. And this is, it was like, still this is about 500 US dollar in Japan. So yeah, high school kid, I couldn't afford it. This served me very well when I was doing all my hobby stuff. But I just wanted to buy a genuine Fluke multimeter, and someday I always wanted to buy a real Fluke to compensate. And it's just cheap one. I just mostly don't use it as a multimeter, just measuring the light. Yeah, it has a sensor here and a measured mic over here. Okay, and last time it was a USB serial console. This is typical Japanese notebook. I don't know what you call this in English. This is shitajiki in Japan. So the ink doesn't go to the next page. It was about 5 volt, and it was about 4 milliamp. So, and emulate the same situation. And what resistor I need is 5.04 is ohm. So, and I don't have 1K 1.250 ohm, so I'm going to put 2 of the 2.2K, and it will be around 1.1 K ohm. So it will be reasonably similar. It might be a little over than 4 milliamp, but it should be close enough. Okay, then I'm going to set up. Okay, I set it as a 5 volt, 0.5 amp limit, and before starting, I want to measure it really has a 5 volt or not. So output on. Yes, 5 volt. Is it possible to see it? It's 5 volt. My camera doesn't have a good exposure adjusting, so yeah, can't help it. Okay, 5 volt is okay. Then let's start measuring the burden voltage. It's set to 5 volt. 2 resistor, the value is 2K2, so it's 1K1 ohm, 1.1 kilo ohm, and 5 volt with 1.1 kilo ohm should be around 4.54 or 4.55, 4.55 milliamp. Last time it was about around 4 amp. So first I'm going to try with the Fluke knockoff. So it's to 20 milliamp range, 4.60. It's close enough. And the burden voltage is 51.2, 51.2 millivolt. It's okay. Then I'm going to change to different multimeter. Okay, milliamp range with 4.61 milliamp, pretty much accurate. And the burden voltage is 33.8, 33.7 or 8, 33.7 or 8. So 4.61 milliamp, 33.8 or 7 millivolt. Okay, the next one is Fluke. And set to milliamp, and Fluke default as AC, so changing to DC, and I tend to change it to manual. So 4.62, yes, pretty much the same, 4.612, and significantly 4.62 milliamp, and significantly lower 8.9, 8.8 millivolt, 8.8, 8.9 millivolt. Okay, next is Keysight. Set to milliamp. Okay, did on 4.61, 4.61 milliamp with 7.4 millivolt. So 7.4, 7.5, 7.4, 7.5. That's the burden voltage. Next is 121 gigawatt or gigawatt or 121 GW. 4.6007 or whatever, 4.60, and burden voltage is 13.3 or 4, 5. Okay, where's my pencil? There it is, 13.3. So okay, I rewrote my measurement here because it was my handwriting was bad. So this one was burden voltage was 51.0 or 2 millivolt, and Mastech MS8209 is 33.78 millivolt, and Fluke 87 5 was 8.89 millivolt, and Keysight U1241B was about 7.45 millivolt, and 121 GW was 13.45. So if the prices, this was about 1985, about $50 or $60, and this is in today, like even in today, it's about I think it's about $40, and this is about 500 US dollar in Japan, and this is, I got this 150 US dollar, and this is about, in US dollar it's about 200. So comparing all these, you can see clearly from here, above and below, the burden voltage is significantly low. I was happy to have these still from and able to compare it. And of course, all have a different ranges, and I only did the milliamp range. All has a different shunt resistor for the microamp range, milliamp range, and amp range. And typically, the cheap old multimeter with the microamp range is about 500 ohm to 800, 900. I need to check this one, and with the probably it's about the same with these. The expensive one is about 100 ohm or something for the microamp range. So and for the milliamp range, when I calibrate it, let me calibrate. 51.2, 4.6 is, so it's about 11.1 ohm for this one. MS3209 is 33.8 divided by 4.61, so it's about 7.33 ohm. Fluke is 8.9 divided by 4.62. Yeah, pretty good. .92 ohm. Keysight 7.4 or 7.5 divided by 4.61 is 1.62 or something ohm. That's nice too. And 121 gigawatt multimeter is 13.5 divided by 4.6, 2.93 or 9, yeah, ohm or something. So 2.9 be around, or 1.62, 1.92, and the cheap one is triple or 4 times larger, 11.1 ohm, 7.33 ohm. But the price also is different. So this is 200 US dollar with 50,000 count, and burden voltage is slightly larger than the Fluke or Keysight, but the price is half of the Fluke, and it has a 50,000 count. So none of them is the best. So there's always, all the multimeters has pros and cons.